I will be talking about Yaskawa SLIO, SLIO system integration. Hi, I am Micah Studeman. Here's a quick preview. The Yaskawa SLIO system is an external I/O system that is flexible and modular, so it can be used for many applications. Over 70 different signal and functional I/O slices can be paired with Ethernet IP and Mechatronic 3 interface modules. Hardware configuration provides a simplified interface to add and remove slices. It also allows you to modify certain slices' parameters and check power usage. The interface modules have a web interface that can be used to set the IP address, view, and modify the slice information. Now let's look at this in a little more detail. The SLIO system allows the motion controller to have access to external inputs and outputs. The design is very simple, so no tools are needed to install it on a DIN rail mount. Each interface module can support up to 64 signal modules. You can have any number of power distribution and power supply slices. Each slice shows the status of its input or output terminals, along with its connection to the interface module. The interface module can transfer data between itself and other slices at 48 megabits per second. Let's look at some of these interface modules. This system has many different interface modules that allow it to communicate across different protocols, like CANopen, DeviceNet, Modbus TCP/IP, EtherCAT, Ethernet IP, and Mechatronic 3. MotionWorks IEC hardware configuration provides an interface to set up both the Ethernet IP and Mechatronic 3 SLIO systems. From this point on, I will be focusing on setting up the Ethernet IP and Mechatronic interface modules. An Ethernet IP system configuration would look like the following. The Ethernet IP interface module is connected to the network switch that is also connected to an MPIC controller. A PC running MotionWorks IEC can be connected to the switch to set up the SLIO device. A Mechatronic system configuration would look something like this. The Mechatronic 3 interface module is connected to an MPIC controller, and the PC running MotionWorks IEC would be connected to the MPIC controller via the Ethernet port. The Mechatronic 3 interface module can also be connected to an Ethernet network to access the web server if the maintenance mode switch is on. Setting up the interface modules in hardware configuration is a very straightforward process. Step 1. You need to find the required address for the device, whether it is an IP address or a Mechatronic address. Step 2. The device can be added in hardware configuration, and the address can be assigned. The SLIO device will then appear in the hardware tree. Like other Mechatronic devices, the Mechatronic 3 interface module will be automatically added if the MPIC controller's config switch is on. Selecting the added interface will open the user setup interface. The user interface allows you to set up your SLIO system whether you have the hardware or not. Many different slices are supported within this interface in hardware configuration. Slices can be added manually to the system by either dragging and dropping them into a slot, or by selecting the slice and using the Add Slice button. Slices can be removed by selecting and then deleting them from the system. If the hardware is connected to the controller, the slices can be imported by getting the online configuration that is on the interface module. And all slices that are connected to the interface module are imported into hardware configuration. Certain slices have parameters that can be set by the user. These parameters can be changed in the parameter section of hardware configuration. Just select the slice and modify the parameter. More information on parameter settings can be found by downloading the manual from Yaskawa's website, yaskawa.com/SLIO. Each slice draws power from the interface module. Some slices can draw a lot, like these digital outputs, which can consume 8 amps, because there are 4 outputs, each consuming up to 2 amps per output. But the actual power consumed depends on the connected load and the number of outputs connected. We can use the load factor to estimate this power. For example, 75% means each slice uses 75% of the max current. The output slices would use 6 amps, not the full 8 amps. The lights signify whether enough power is theoretically being supplied to the slices. Power modules can be added to provide the required amount of power for the slices inserted after them. This creates a new circuit for the slices after the power module. After saving the hardware configuration, the Global Variables worksheet will show all of the variables that were created for the attached slices. Here, I am flipping the switches to test their functionality. I see it works in debug mode, and I do not have to figure out the addresses like I would have to for a third-party remote I/O device, because hardware configuration sets the addresses for me. The Ethernet IP and Mechatronic 3 interface modules have a web server that can be used for performing diagnostics, checking module status, and configuring the SLIO system. So what's the difference between Mechatronic 3 and Ethernet IP interface modules? I've made mention of both of them up to this point, but which one should be used in which scenario? To start off, Mechatronic 3 is deterministic, compared to Ethernet IP, which is non-deterministic. Deterministic networks provide better communication for motion networks because the transmitted data being sent is scheduled and received at a low latency rate, compared to non-deterministic networks where transmitted data occurs within a time band, but the packets are not transmitted and received at a constant rate. In the case of Ethernet IP, since it uses UDP, User Datagram Protocol, to transfer information, the master cannot verify whether the slave has received the information or not. So there is potential for the slave to miss packets of information. So in this case, Mechatronic 3 should be considered for time-critical I/O, compared to Ethernet IP, which can be used for non-critical or operator I/O. These two interface modules also have varied support for some of the function modules, as seen by the following table that you can find on Yaskawa's website. One major difference when using the Mechatronic 3 interface module versus the Ethernet IP interface module is how parameter values are stored after a reboot. When using an Ethernet IP module, the parameter settings are saved in the MPIC controller. So when the SLIO system performs a reboot, the parameter settings do not revert back to default because the controller writes the save values upon reboot, as long as it was enabled in hardware configuration. When working with the Mechatronic 3 module, the parameter settings are not saved in the controller automatically. So when a system reboot occurs, the parameters are set back to their default settings. While this is different, it is not a problem. Don't worry, the settings are easy to save in the MPIC controller. Two function blocks are available that allow the parameter settings to be saved in the MPIC controller. These function blocks are the ymlink IO read parameter and ymlink IO write parameter function blocks, which are included in the ymlink IO firmware library. The ymlink IO read parameter function block takes the parameter value and stores it into a variable on the controller. When the SLIO system reboots, the ymlink IO write parameter function block writes the value back to the old value instead of the default value. To wrap up, let's look at some of the slices that are available for the SLIO system. The interface modules automatically come with one 10 amp power supply module. More power modules are available depending on the power requirements of the slices within the system. The 4 amp power slice provides an additional 2 amps of bus power, which is used to power the logic parts of each slice. Potential distribution and clamp modules are available to provide power from the main power supply modules for external devices. These external devices could be limit switches or proximity switches. There are many different signal modules that are available for use within the SLIO system. Signal modules are your basic digital and analog input and output devices. Looking at the digital input slices, there are 2, 4, and 8 input slice modules that work with 24-volt input devices. There are slices that can be either PNP, voltage sourcing inputs, or NPN, voltage sinking inputs. Some slices have an available filter built in for time-delayed inputs. These input modules are used with a variety of different devices, like push buttons, photoelectric eyes, motor starter contacts, and relay contacts. Digital output modules are available also in 2, 4, and 8 outputs per slice. These slices work with 24-volt devices. Different modules are available for different applications. For instance, the PWM module is made to control simple fans, heaters, and other PWM controllable devices, where the relay module allows switch control of higher voltage and current devices in applications like motor contacts, fans, and horns. The basic slices are commonly used for signal lights, valves, and solenoids. Analog devices such as flow sensors, pressure sensors, temperature sensors, force sensors, and potentiometers can be used with the SLIO system using the analog functional signal input slices. The input slices can have 2, 4, or 8 inputs. The standard slices can receive analog information and process it as either 12-bit or 16-bit values. These inputs can either be voltage-driven or current-driven. Specialty analog functions are available, such as thermocouple, resistance measurement, 24-bit strain gauge, and energy measurement. Other analog devices such as analog meters and gauges, along with PID controller devices, can be used with analog output slices. These slices offer 2 to 4 outputs with either 12-bit or 16-bit output sampling resolution. These output slices can provide a voltage or current signal to the external device. More advanced slices are available to be used with the SLIO system that provide complex functionality for certain applications. 2 of these slices give the MPIC motion controller the ability to command motion using DC motors or stepper motors for non-critical parts of the application. These motors are controlled within MotionWorks IC by writing to predefined variables that are created by hardware configuration for these slices. The counter function slice provides a hardware counter solution that allows high-speed latch value capture, value comparison, configurable input filters, and AB encoder input. Some applications that may benefit from this slice are rotary knives and high-speed placers. The frequency measurement slice provides the frequency or duration value of the incoming analog signal. The SSI encoder slice provides another way to capture or send absolute encoder data. This slice is used in master and slave scenarios where position data is critical. The pulse train output provides another method for sending velocity commands to simple devices, like Yaskawa analog servo amplifiers and AC drives. Communication slices are also available on the SLIO system. The serial interface slices allow the SLIO device to communicate with RS-232 and RS-422/RS-485 compatible devices. These protocols are commonly used to communicate with legacy or simple machine devices. Thanks for watching this video. Go to yaskawa.com/IECSW to download the latest version of MotionWorks IEC3 and try out these features yourself with a 30-day demo.